So the paper I'm looking at is researching dopamine neurons in the ventral tegmental area and whether or not these neurons have the same function or if there are subset functions for these neurons. So to do this, researchers placed a GRIN lens above the ventral tegmental area in the mice's brains and used a fluorescent drug that glows when there's neural activity along with a 2-photon microscope to image these neurons. So the mice were given a behavioral task. They're basically set up in a virtual reality maze situation, and they were cued in the maze to go a certain direction. If they followed this cue, they were given a reward, and if not, there was like a tone and a timeout for them. So the researchers found that during the cue period, when the mice were cued to go one way or the other, that these neurons had a variety of functions. They weren't all doing the same thing. But during the outcome period, which is when they were either given a reward or a punishment, that these neurons mostly dealt with reward processing. So to find or to identify which neurons were firing in regards to what function, the researchers used the dye and the 2-photon microscope to graph the change in fluorescence of these neurons and looked at a few different functions. So one thing they looked at was position, which is basically just the mouse's positioning in the maze. And they found that 91 out of the 303 neurons imaged were involved in positioning, and they took one of the neurons out of the 91 and made a graph of its change in fluorescence, and basically found that there was a pretty linear increase in its firing rate as a function of the position in the maze. So basically the farther in the maze the mouse was, the more that neuron fired. So that's just an example of one of the subset functions that these neurons displayed and a factor that can determine its firing rate.